Hello guys, welcome back. In this video, let us learn one more interesting concept regarding Redshift. We create Redshift clusters, right? Yes. In that, we will store our data and we will even process our data. Now the question is there any limit? Is there really any limit for storing my data under Redshift? Yes, there is a limitation as well. Within a single cluster, you can store up to 2 petabytes. How much storage? Within a single cluster, single Redshift cluster. Within a single cluster, Redshift can able to store how much storage? Up to 2 petabytes only. So this is one of the important limitation that you need to remember while using Redshift. Redshift can store only up to 2 petabytes in a single cluster. So like this, you can create multiple clusters in your account, but the only limitation here is a Redshift can hold up to 2 petabytes of data only in a single cluster. So let's say I have a Redshift. In this, I am maintaining one cluster where let's say I am the owner of a car company. Now, in 2023, a new model was launched. The name was Spark. The name of the model of my car was Spark. So every data related to Spark, every data related to Spark car will be stored under this cluster. Let's say my data will reach to petabytes. My data will be reached to petabytes regarding these car details like manufacturing or whatever the data incoming or whoever the customers offering. So all data regarding to this model I stored in this cluster 1. This is regarding 2023. Now for modernized changes and customer need, what happens is my customers, I'd like to provide one more new branded car. I have developed one more new branded car. That model is Super Spark and I launched it in 2024. Now what happens for this model also? I need to store the data related to this model, right? Yes. So for that also I used Redshift and I created another cluster and I stored my data related to this Spark, Super Spark. It is also reached to some petabytes of data. Now I am charging for my cluster 1 and I am charging for my cluster 2. This is just an example. I am charging for both the clusters, right? Yes. Since I am storing my data and querying my data frequently, I charge for the both clusters. Let's say my new model, what is that? Super Spark. That was clicked in the market. That means most of the customers are frequently accessing this cluster 2 compared to cluster 1. This cluster 1, after some time, what happens is in the market, new model cars came so that most of the users are not using the data related to this Spark model. So, how much frequently my this cluster 1 is accessing is very infrequently. So very infrequently my cluster data was accessed. So now what happens? I'll still pay the same charge for this cluster 1 as well as cluster 2, right? Yes. So here if you see about cluster 2, this cluster 2 was accessing very frequently. So I'm happy for paying for the storage for this new model, that is Super Spark in cluster 2. But I am not satisfied with cluster 1 because my users are accessing the data very infrequently, and still I am maintaining my data under my Redshift database, and I will be charged a lot for storing this much amount of data, that is petabytes of data. Now what happens? I have a need now. What is the need? I want to put this data somewhere. I want to put this data somewhere, and I want to access it infrequently, whereas my charge will be less. Whereas my charge will be less compared to storing this inside this Redshift cluster. So for that, I'm searching for a service inside my AWS. Initially, I thought to delete this cluster. Whatever the previous Spark model is there, that database I'd like to delete. So if I delete this, what happens? If I delete this, the data which is present under the cluster will be gone. That is, the data under the cluster will be finished, erased. You can say, yes. So my data will be erased. Now what happens? Some of my customers are trying to access this old version of my car data. Now, do they get my old version of car data? No, right? Yes, they don't get this data because this are already deleted. So, in order to avoid it, do I delete it? No, there is no option of deleting this data. I must need to store somewhere, and I need to access it infrequently. That is the scenario that I am facing now. Keeping this Spark version car data inside my Redshift cluster is now becoming very expensive to me. That is, it has now becoming a major issue to me. Now, in order to overcome this issue, AWS comes with another feature in Redshift. What is that feature? Redshift Spectrum. What is that feature? Redshift Spectrum. So, in order to fulfill our needs under Redshift Spectrum, what we do is we just put our data inside S3. So, whatever the data which is maintained by cluster 1, that is infrequent accessing data, that we will put under S3. So, since it is infrequently accessing data, we can even call this type of data as cold data. So in this Redshift spectrum, we just move our cold data to S3 inside bucket, and we can able to access that data by using this Redshift cluster. By using this Redshift spectrum, we can able to access that data. So whatever the data that we put under S3, we can able to access that data by using queries. By using SQL query, we can able to access the data which is present under S3 by using Redshift spectrum. Let's say now we move this cluster 1 whole data that is related to Spark model. My car data related to Spark model, that whole data is moved to S3. Now my data is stored for less charge in under S3 storage. In one of the storage type, I stored for less storage charge. Now, in order to access the data which is present under S3, that is Spark tables, the tables of this Spark which is present under this S3, how can I able to access? You can able to access by using SQL queries. So by using this Redshift spectrum, you can able to access the data which is present under S3 by using SQL queries. So Spectrum uses SQL query to access data that is stored under S3. So what spectrum uses? It uses SQL queries to access data which is present under S3. Now, by using spectrum, we can able to query the files which are present under S3. This is one of the interview question. So just concentrate on it. By using Redshift spectrum, we can able to query files which are present under S3. Yes, we can able to query the files which are present under S3 by using Redshift spectrum. Now, what the files will store? Files will store automatic tables, right? Yes. So files will store tables. Now let's say I want to provide a communication, or else I want to join the tables. I want to join the tables which are present in one table is present in my cluster 2. That is, I want to join super spark table with spark table. But actually my spark table is stored as file under S3. Now, can I able to join? Can I able to join whatever the file which is present under S3 with whatever the table which is present under my cluster, Redshift cluster? Can I able to join a table which is present under Redshift cluster and S3? Yes, you can able to join the tables which are present under your cluster and the table which is present under your S3. The table is stored here in the form of files. We call those files as objects under S3, but we call the data which is stored under Redshift cluster as tables, right? Yes. So now what I'm expecting, by using this spectrum, what we can do? Can we able to join tables under Redshift cluster and S3 data? The answer for this is yes. By using spectrum, we can even able to join between tables of Redshift cluster and S3 data. So by using spectrum, we can able to join between tables on Redshift cluster and S3 data. Since the data which is present on our cluster, we are frequently accessing, can we call it as hot data? Yes, we can even call it as hot data because we are very frequently accessing that data. So we call the data as hot data as well. Okay. Now, what we are doing by this, what we can able to do by using this spectrum, we can even join our hard data with whatever the data which is present under S3. That is nothing but cold data because we are infrequently accessing, right? So that is nothing but we are joining frequently accessing Redshift cluster data and infrequently accessing S3 data, right? Yes. So by using this spectrum, we can seamlessly work with both cluster data as well as S3 data at a time. By using this spectrum, we can able to work both cluster data and S3 data at a